Hello students! Today we are going to be covering chapter 4 of your textbook, covering the topic of proportionality. Proportionality comes in two flavors. You have direct and inverse. And this little box was pulled straight from your textbook, but your textbook absolutely nails it. Direct proportionality happens when as one quantity increases, the other quantity also increases. And inverse proportionality happens when as one quantity increases, the other quantity decreases. And then the rate of change between the two quantities, that's what we call the constant of proportionality. Essentially, that constant of proportionality captures that relationship between your two quantities. And we'll see more what I mean when we do some examples. But let's first look at calculating the constant of proportionality. So in direct proportionality, you have a situation, maybe you have two quantities A and B, and as A increases, B increases. In this case, you would calculate the constant of proportionality, or sometimes called the rate of proportionality, that is B over A. The kind of relationship here is something like A is causing the increase in B, so B depends on A, and in that case, our constant of proportionality will be B divided by A. And let's look at an example. So suppose you make $36 working for 3 hours. I guess the first question we should ask ourselves is, are we in a situation of proportionality? Is it true that a constant change in one quantity results in the constant change of another? And often it is. This is often how we get paid, is that, okay, well, you're paid by the hour. And so as you increase the number of hours you work, you increase the amount of money you get paid, and that a constant increase in the number of hours results in a constant increase in the amount of money you get paid. So yeah, we are in a proportionality situation. And it's the case that as the number of hours you work increases, then the amount of money that you make increases. And so in this situation, it seems like the amount of money you make depends on the number of hours you work. And so just make sure you understand, maybe take a moment and calculate the constant of proportionality yourself. You might pause. But okay, if you did that correctly, you would end up with the amount of money you make depending on the number of hours you worked. So you have your constant is your B over A, 36 over 3, which is $12 per hour. And so when I said earlier that the constant of proportionality captures this relationship between the two quantities, this is what I mean. It's like, this is your hourly wage. This is why, as you increase the number of hours you work, the amount of money you make increases at a constant rate. And it's because you are paid an hourly wage. You're paid, by the hour. And the relationship between those two quantities is just that, all right, you're paid by the hour. How much? You're paid $12 every hour. So a question I've gotten in the past when teaching this course is, why not A over B? Like, why is the constant of proportionality B over A instead of A over B? Especially when maybe you don't know, like, if one is causing the other. All you know is that as one quantity increases, the other one also increases. So what's to say one is causing the other? So why not A over B? Well, let's see what we would get if we calculated A over B in this situation. In this case, we'd get $3 or 3 hours divided by $36. And so we would get 1 over 12 hours per dollar. And this is actually telling us something meaningful. This is telling us how many hours we need to work to make $1. And it's 1/12 of an hour. So actually, both B over A and A over B are they contain the same information. Both of them are telling you the relationship between the two quantities. The information is just reversed. Here, they're telling you how many dollars you make in an hour, and here it's telling you how many hours you need to work to make $1. And so, which one you choose, whether you do B over A or A over B, it just depends on what makes sense in the situation. Usually, in a situation where it's clear one thing depends on the other one, like B depends on A, then you would choose B over A. But, um, yeah, you might run into a problem where either one makes sense. And in particular on the homework, if you run into this, if either constant makes sense, then either constant will do and will get credit. So long as you understand, the units and what you just calculated. Okay, so let's do another example now with inverse proportionality. So here in this case, we have as A increases, B decreases. In this case, the constant of proportionality is A times B. So, okay, you don't have to worry about order in this case. You get the same constant, whether you think of A depending on B or B depending on A. So that's nice. Let's look at an example. Suppose 4 people can paint a fence in 3 hours. And it does seem like we're in a case of proportionality. The more people you have, the less time it takes. If you want to have something done in less time, you need more people. And yeah, so as the number of people increases, the amount of time it takes to paint the fence decreases. So this is our proportionality setup. What's the constant of proportionality? Well, our quantity A is going to be people and our quantity B is going to be hours. And so our constant of proportionality here will be 4 people times 3 hours, which gives us a proportion like 12 people hours, which is something you might be familiar with. These inverse proportionality problems, sometimes the constant of proportionality is something we're less familiar with. We're much more familiar with direct proportionality and the idea of rates than we are with inverse proportionality and a rate being something like people hours. But okay, this just tells us how many hours of work you need to complete the fence. How many man hours, how many people hours. Like if you're a contractor, how many hours of work do you have to pay for to complete this fence? You have to pay for 12 hours of work. So let's do a proportionality problem. Let's actually, solve some problems with these constants of proportionality. So, all right, from our example before, suppose you're making $36 working 3 hours. So your constant of proportionality is $12 per hour. How much money would you make working 5 hours? This is, a question you could see on your practice problems or in the homework. And, okay, I'll give you a second to work this out yourself. Pause it. Well, okay, you take your constant of proportionality, $12 per hour, and you multiply by the number of hours you worked, and you end up with $60. And if you're not sure about what to multiply by what, then it's you can always look at the units and say, all right, well, I want to cancel hours, so I'm canceling my units. So that's how I get to 60. And I guess maybe I'll say, like, how did I know to multiply by 5 hours anyway? Well, it's this constant of proportionality. That's your B over A, and it didn't matter what your B over A was. Here, our B was 36 and our A was 5 hours. Here, our B, we don't know, and our A is 5 hours. And so that's how we know, that's another way to know that you need to multiply by 5 is this is our constant of proportionality, set it equal to our proportion, and then solve for the part we don't know, which was the amount of money you make. Okay. So now let's do an inverse proportionality problem. So here you've got 4 people can paint a fence in 3 hours. So we know that our constant of proportionality is 12 people hours. So I can ask you, okay, well, how many hours would it take 6 people to paint the fence then? And here, well, we've got 12 people hours spread out over 6 people means that you have 2 hours per person to work. And again, you can think of this 2 ways in knowing what to divide or whether to divide is you can say, all right, well, I want to end up with hours. I have people hours. So like the units just mean I should cancel out the people. So I should divide by the number of people. The other way to realize it is that, okay, you've got your 12 people hours and that's equal to A times B. And here your A is 6 people. And this is taking a long time to write out on this. Forgive me. Also, it's one of these situations where I've written people so many times in recent memory that the word people has lost all meaning for me. Like I look at it and I'm like, that doesn't look like a word to me anymore. Anyway, okay, so you have 12 people hours and then, whoops, that equals 6 people. Great. And now I've lost my ability to see my mouse. Well, okay, so it's 12 people, hours equals 6 people times, here, let me just, here we go, times B. And now you solve for B, which is the number of hours. Okay. Let's clear the drawings. And so now let's ask, okay, well, how many people would it take to finish in 2 hours? So try this on your own. All right. And if you did that, well, it's the similar setup. You've got 12 people hours equals 2 hours times A people. And so solve for people and you get 12 people hours divided by 2 hours. Hours cancel. You get 6 people. And that's good. Since earlier we said it takes 6 people 2 hours, then if you want to finish the job in 2 hours, you need 6 people. All right, and that is it. Thank you for watching.